Hey, hi everyone. Today we are going to talk about web attacks. Hi, I'm Lucas, by the way. I'm teaching for the first time this year, so hello. It might be a bit more challenging today for you, but I hope that it's not going to be that bad. So, first of all, feedback from the last class. It looks like most of the stuff was all right. I will try to go a bit slower, and we will see how that goes. Please, if you get lost, let me know. I will slow down. I will try to explain more and talk more about like what we are doing and maybe experiment a bit. Okay, so first of all, Pioneer classes. Congratulations to all of you who actually like did the assignment. This one was like very tricky. So do we have our, yay, we do. Awesome. So third place, set of 300, really 300 LED? 300 LED, they are the odds. Awesome. So Tomáš, do we have Tomáš, Pavli, Tom? No? Yay, please, if you are watching, come for the prize, otherwise we will take it and give it to someone else.
Does it expire on Christmas?
Yeah, I think so, because we need
300 LEDs, they are very useful.
Right? It's very cool. Next one, second place with Raspberry Pico. Ooh. And Luboslav, Moto Sloop. Hey, congratulations. Yay, do we have Pico? Yes, we do. Here you go. Congrats. And Siduino, wow, that's very cool. So first place goes to Jan Hofer Jan Honza. Hey, congrats! Awesome, enjoy. Thanks. Cool. Now, special announcement about exams and bonus and bonus. We do have exam dates, so please note them down. This is when we will hold the exams probably here. Yes, here every day. So it's January 21st, January 23rd, January 30, and February 6th.
Lukashi?
Yes.
I will jump in. There is slight change in the first date because of a collision with other exam. It's been moved 30 minutes, so we will start at 3 and finish at 5 in the first exam date. Otherwise, it's the exact same dates that we announced last week. So this is the only change. There was a little bit of collision, so we had to move a little bit.
Yeah, but as far as we know, like this is final, right? Okay, awesome. So this is final. There are also, as we said before, there's going to be a bonus assignment, which essentially allows you to skip the exam. So if you finish the bonus assignment, you don't have to go to the exam, and you will get essentially the same amount of points as from the exam. So we definitely like recommend going through the bonus assignment. We'll announce it and actually launch it like next week. Is it next week? Yeah, December 20 looks like next week. So, and we will talk about it more in the next class. For everyone who is using Stratos CyberLab, please pull the latest changes and launch the class 12 right now. It takes a lot of time to launch. There is some non-trivial stuff going on, some Docker containers building and stuff installing, and it takes, I don't know, 12 minutes, something like that. So please do that now. For everyone else who is sitting here, who is in CTU, everything is already installed inside your containers, so you should be just fine. All right, so what are we going to talk about today? First of all, we will show how to find stuff on the internet, how to do something that's called reconnaissance. I have no idea how to write this, but it's essentially a state or action how to find stuff. Then we will talk about most common vulnerabilities there are on the web and in web applications. Then we will analyze and go into detail in two of them. One is called cross-site scripting, the other one is SQL injection. And at the end of the class, hopefully we will manage to do it, I will show you how to mitigate those issues. So not how to fix the code, but rather how to mitigate and how to like enhance your security or security of your applications. All right, so let's go. So what is web? That's kind of like a very abstract question, but what do you think is web? Is it like google.com web, or is, I don't know, localhost web? So web is, yeah, Seba said that it's where the stuff is. I think 2 years ago, that was great. That's kind of like a definition of what the web is. But in general, it's like a lot of services connected to each other, and it's like very complicated. And whenever there's a complexity, there are also problems that arise with this complexity. So vulnerabilities, hey, and how to exploit them, right? So again, like, is google.com just a web page? Is just a, I don't know, HTML? It's not, right? I mean, there's tons of stuff going behind this simple HTML site. So there are, like, as I said, like, there are many services. Like, some of them are running inside your browser. So those are like the client side. It can be, I don't know, JavaScript. It can be web application. It can be mobile application. It can be application installed on your laptop. Then there are some middle boxes that are like load balancers, proxies, and whatnot. Again, some service that runs somewhere that's talking to something else. And there are so many of these that, and they talk to each other. So it's a like convoluted network of stuff talking to each other and having protocols that allows them to talk to each other. That's a lot of complexity, right? So that's the problem. Or for us, when we are exploiting stuff, it's actually good, right? Because there's a lot of stuff to exploit. We can exploit, I don't know, the client application. We can exploit proxies or the middle boxes. We can exploit servers. We can exploit databases. We can exploit like essentially anything on this huge attack surface of something that's application. By the way, attack surface, I didn't define what that is. Attack surface is essentially like everything that is exposed to the internet. So it's maybe database, it's maybe server, it's essentially everything that you can touch. All right, first of all, I will show you something that's called Avast Juice Shop. It's a test application that was developed intentionally vulnerable. So you can try to pen test it, you can try to destroy it, you can try to hack it and everything. And in today's class, we will be using this one for everything that we do. So it's a safe environment. It was designed to be, well, safe environment, right? I mean, it was designed to be unsafe. So we will be using that one. There is some documentation on the web. You can find even like the you can even find trainings and guides how to exploit it and what to exploit it. We will do just a subset today. We did launch our own instances for it. So first of all, what you need to do is to port forward from your containers to your localhost so we can access it with the browser, okay? There are separate instructions for CTU students, so please, in CTU, we will be using these 3 instances. And you need to run this nice command that will essentially port forward port 3000 from Juice Shop to your localhost. So please make sure that your computer is not using port 3000. There might be some web applications running and whatnot. And we will be using also port 8080. That one is for a different application, but we will show it later. There are 3 instances. So, you know, when somebody breaks it, we have 2 more. So how do we split it? So this part of the class, you are number 1, please. So you run this first command, right, with the Juice Shop number 1. This part, like this, yeah, and over there, are number 2. And I guess we are number 3, something like that. It can work. So please do the port forwarding right now, because we will be using everything that we will be using the Juice Shop later on during the class where we get to it. For Stratos CyberLab, this is a bit more complicated, but still, I really believe that you can do it. First of all, you need to launch class 12. As we said at the beginning, it might have been already running, so please do that. Then log in from the default terminal from the Hacker Lab. So when you open the website, there should be this, right? And log in with SSH root class 12 and put admin as a password. This will give you access to all the kind of hacking tools that we are going to use today. And also, there's another one which you need to do from your own computer. So please do not do it from the browser. Do it from your own computer, from the command line. And you also need to run the port forwarding like this. And when this command asks you for password, please put bidem123 as a password. All right? Please let us know if you have any issues whatsoever with either Stratos CyberLab or you guys actually sitting here. The result should be that you are able to go to localhost 3000 and you should see this. So let me try to run my port forward. And now when I go here, yeah, I have this. So please do that. Otherwise, you won't be able to follow this class because it's going to get a bit more tricky. Any questions so far? Are you able to see your localhost 3000 showing you the Juice Shop? Yes? All good? Awesome. Love it. Great.
The internet?
The internet. Do you have any question, mighty internet? Yes.
People from the internet ask, what is all this stuff on the table? Is part of the class?
So no, this is not for our class. There's a robotic competition going on in the university, and this is a playground for the robotic competition that's gonna happen next week, this week, today, tomorrow. Yeah. So I think this is actually finals. So if you want to watch finals, I think we can get you a YouTube link.
Can you show the SSH command again for people? Can you explain it again?
For internet or for, okay.
And while Lukáš is sharing it, if you'd like to see the robotic competition, it will be broadcasted in the live stream link in the same live stream link, so you can watch that tomorrow.
So you need to run this from your browser. So let me actually go and launch it because it might be better for you. Okay, so I go here, web attacks. Yay! I run start. It's gonna take a while. I should have done it before, but the idea is that after it actually starts, please run this from the browser, and then run this from your local computer. Okay. Right? So you run this from your local computer. You run this from the website once it loads, okay, from the terminal in the lab. Please let us know if this is okay, or we can go through it. We can go through it again. This is tricky. Sorry about it, but we will be using a lot of stuff today. Okay, so did it launch? No. Okay. Anyway, yes. You are CTU student. Okay. So inside your Docker, you don't have to right now. Inside your Docker, we installed all the tooling that you will need during the day. So there are, stuff. Right now, the only thing that you need is like this command that's gonna port forward Juice Shop inside your own computer. So what we are right now doing is accessing internal network of the containers, so the network that we are doing on our server. and we are port forwarding one of the services to your own computer. So your own computer right now thinks that there's a Juice Shop running, even though you didn't have to install it. Okay? Any other questions? Are you able to access Juice Shop? Awesome. Martin, yes, great, thank you. All right. Did we launch? Oh yeah, here did we actually launch. So let me show you the another command that I had for remote students. And it's not doing anything, and this is not great. Okay, I'm having some issues with StratoCyberLab. I will probably need support as well. But anyhow, let's talk about the first thing that you do when you decide that you want to actually attack someone. And it is intelligence gathering or reconnaissance. It's a process of obtaining all the information that you need or that you require in order to attack someone or to do pen test or to do essentially anything. You need to figure it out what they are running, how they are running it, and where do they run it. So you are looking for infrastructure, software, even processes, and maybe even people. Because, you know, like social engineering, hey, you are looking for people that are working in this company, right? And the generic goal of this is to figure it out as much as we can before we move to actually like exploitation phase or vulnerability finding phase, okay? So that's reconnaissance. And right now we will talk about like a first way how to do like reconnaissance. And it's actually like Googling, right? Actually, Google is probably the best hacking tool ever created because there's so much stuff that you can find just by searching for it, right? So let me show you. We talk about okay, so sorry. Actually, it's not just Google, but it's the advanced search in Google. It's this, when you click here, you will get a lot of different options what for to search. You can search all of these words, this exact words, blah, 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 blah. There's a ton of stuff. Please go and explore if you want to. But there's a query language that you can use. So, you know, they have shortcuts for it, so you don't have to really go into this UI. The most useful keywords from here are in URL, in title, in text, dash, site, file type, extension, or. In URL, what it's doing is when you write in URL something, so if you write, I don't know, in URL this one, this is awesome. So it's searching for, give me everything where the URL contains WP content. Okay? So it has to be part of the URL. And when you search for it, what's the WP content? Do you know? Yes. Exactly. Nice. This is where WordPress stores stuff. And I don't know, should this be open? Does it look like that it should be available on the internet? I mean, db.php, wow. That's pretty nice. And there's tons of this. Oh, this also looks okay. Not sure this should be open. Maybe yes, maybe no. I don't know. There's another one. Open directories. Hey, give me open directories of some projects. Should this be open? I don't know. Again, but it's on Google, so you can try to search. I don't know. You can explore what is there. Another one is okay. Give me in title. So if you know index of is inside the title, which means it's probably an open directory. And inside URL we have etc. What's etc? Do you know what's etc? Sorry? Exactly, it's a Linux directory, right? So we are essentially saying, hey, give me all open directories that you have that also contains etc. So what this search gives us, Okay. Oh, this is nice. Reklama, sortable statistica. Okay. What's here? Something more interesting? Oh, what's this one? etc pass WD. Oh, that's bad, right? I mean, you really shouldn't expose like these files into the internet. I wouldn't say we just hack someone, but man, we just Google, like it's literally just Googling. Yes, Martin. It's a honeypot. Yeah, this is what I think about like 80% of the internet. Whenever I am either searching or just browsing and seeing some weird stuff, it's like, yeah, this is a honeypot, right? I don't think Etego Brazil is a honeypot, but maybe it is. I don't know. Let's try another one. Oh, wow. So much stuff. Oh, again. This is cool. So many users. Okay, so as I said, this is just like searching for weird things on the internet. And as you can see, there's so much of that. Okay? Everyone, we'll try this with our own website, with Stratosphere IPS, and we will look for all the PDFs there are. So we have this paper. Oh, hello, Vero. You have your CV over there. So you can search for specific files. PDFs, okay, PDFs are interesting, but how about something a bit more confident, let's say? So what about configuration files? Ooh, configuration files. What is this? Oh, okay. Config PHP, that sounds somewhat fishy, but how about databases.yaml? Okay, so it's just a root localhost DB name. Yeah, but there's a password. Hey, we just found the open database. It's on localhost, so it's not that bad, but you know, you get the gist. So you can actually search for open databases like that. How about this? So what this one do? This one is searching for JDBC. There also must be username somewhere in the file, password, and it has to be YAML, right? Or it has to be actually .java. So if I do this, the problem is that I'm getting a lot of false positives, right? Because, hey, Oracle, this is actually, this is example, so this is not that interesting. Okay, this one really looks interesting. Oh, we are here. Oh, wow, that's great. GitHub, not that interesting. Okay, there are probably going to be a lot of GitHubs because, you know, like GitHub is also indexed. So if you search for Java files and JDBC string, you are probably going to, you know, end up on a GitHub. So what you can do is you can use like a negative search that essentially says, hey, give me everything for this query, but there cannot be Git word or GitLab or GitHub or help or whatever. So if you do this, oh yeah, there are 700 false positive in PostgreSQL documentation, but there can be other interesting stuff. Oh, I closed my document. Sorry for that. Damn it. Now, where was I? Yes, we were doing this. Another very interesting search is exceptions. Because if your application breaks and it like prints some exception into the HTML response, it can still get indexed by Google, right? And sometimes people do not sanitize what they are showing, and there are some default behaviors of the frameworks showing everything. Okay, so including queries, sometimes even including JDBC strings, or essentially like connection strings. So how about this? Oh yeah, we are getting a lot of backtrackers and whatnot. So that's not really interesting. Okay, forums, also not great. So how about this? Yeah, we already put forum. We put that we don't want community. Oh wow, thank you. Oh, thank you. Okay, maybe bugs. I don't know. Okay, wow, this is nice. SSL version, whatever. So this is broken. Maybe this one. Oh, how about this one? It's already 4.4. So the thing is, it's not. Oh wow, nice. Oh, we are getting. Oh wow, this is cool. Hey, user SQL. Wow, using password. Yes, but where's password? Oh, good, they don't have password. So at least that. But so the idea is here that a lot of stuff is already on the internet, like wide open. You could just Google for it, grab it, and do whatever you want to do it with it. The part with do whatever you want to, please do not actually try to hack anyone. This is very illegal to try to actually hack, right? So please do not do that. But you can use this when you are doing, for example, pen test of a company, because these companies have their stuff on the internet. Just recently, 2 weeks ago with Martin, our company reported this to 2 separate companies, that they have exposed connection strings to their databases indexed by Google. Okay, so this is not a theoretical exercise. Like, people do make mistakes. These mistakes get indexed by Google, and that's it. Like, your credentials are exposed, and everybody can just grab them and do wild stuff with it.
Yeah, so I can add, so the difference of what Lukasz is saying with what we are doing now is that the information we are looking at now is open in the internet. So it's like putting a poster in the street, right? Like you go there, you walk, it's there, you can read it, you can grab the poster and take it home, right? But you cannot use the poster or the key that you find in the street to try to break into some place. When you work for a company doing a pen test, what Lukasz is saying, that the same tools can help you leverage the information that is already public to make the assessment faster. And the difference is that when you do a pen test for a company, the company gives you a scope, and the scope tells you what exactly is included, and then you can put that scope in a way into tools like Google Dorking, and to speed up all your information collection. So the tools that Lukasz is showing is actually a way how to not spend 4 weeks looking for information by yourself, but actually leveraging Google that does the work for you, right?
Yep. So, first thing when you are doing pen test, or you are trying to, I don't know, do some bug bounty hunting, just Google for stuff, okay? Use whatever tools you have and try to find weird shit on the internet for given company, okay? For the one that actually gave you consent to do that. One thing, so how can you protect yourself or your site from being indexed by Google? Do you know? Anybody? No? Yes. Exactly. So there's a robot.txt. I'm not sure if I can do it like this. Yes, can you see it? It's so there's a robot.txt where you can actually say, please do not index this site, or do not index this part of the site. You can also use meta tags that says meta name robots or contact no index, or you can even use headers. You would want to do that for sites that are user applications that do not have any public content, that are only behind login. You can do this for it, but the thing is that Google does not have to respect that. If it's open, they can just access it, right? They are trying to play nice and saying, okay, we will not index it, we will not show it to people, but nothing is actually physically preventing them to do that, or anyone else on the internet, okay? So this does not protect you in a way that you would be safe, but it's some sort of a mitigation, how to not to end up in the open index. Okay, so application discovery. Right now we are able to find weird stuff on the internet, connection string, file, and whatnot. Now we have to find running applications, okay? Because we want to exploit specific application. So applications are usually deployed either behind a new domain or behind a new subdomain, or they are deployed in like a different path. So for example, when you are deploying GitLab, whatever, you either deploy it like gitlab.mycompany.com or you deploy it mycompany/GitHub, right? Or you buy github.mycompany.com, like a separate domain for it. Now, domain, as I said, like domain is a human readable identifier that has like a hierarchical namespace to organize and access resources on the internet. So it's like example.com, that's a domain, right? Subdomain is company.example.com. How DNS works. So DNS, are you familiar with DNS? It essentially translates domains to IP addresses or to data. So for example, TXT records that are part of the DNS are data assigned to some specific domain. So when you request, hey, give me all TXT for google.com, you will get some data, you won't get IP. But when you say, oh, hey, hi, give me please this IP address for this domain, you will get an IP address. However, there is like no query that's like, okay, translate IP address to a domain. So you cannot say, hey, okay, give me all domains that belongs to this IP address. Like this query does not exist. Okay, it's only one-way street. And there's also no domain, or there's also no query or request that says, hey, give me all subdomains for this domain. Okay, so you cannot like simply ask someone or ask DNS, hey, give me everything that you know about this guy, right? I mean, that sounds like a privacy issue, maybe, I don't know. But it's the way how DNS works. So when you are mapping what somebody runs, we need to check all possible places where the application runs. So we have to find all the subdomains, okay, about the company or about the people who run it. So we have essentially three options. First one is we just Google for it, as we did right now. This one is kind of okay, but you know there don't really have to be like all the subdomains that we are looking for. We will not get the same subset. We can try to brute force it. So you know we can have a word list of I don't know most common subdomains and try to resolve it or even access it and figure out okay, is this a real domain or is this a real application and whatnot. The problem with brute forcing is that it's kind of dumb and it's like, okay, you have to wait really. And if you have, I don't know, môj lutočký kůň or whatever weird domain that you only know, you will not find it, right? But there's a third option that is called Certificate Transparency Project. So Certificate Transparency Project is essentially a database with all certificates ever created. Okay, it's like a huge database of all the certificates that were ever issued. These certificates can be, I don't know, HTTPS certificates. So if you get your HTTPS certificate from Let's Encrypt or from any other issuer, the certificate will definitely end up in in the Certificate Transparency Project. Okay, so you can actually search for it, and you can find it. And nowadays, like almost every single site is using HTTPS, right? Or like, when is the last time where you actually used some website that did not have HTTPS? Do you remember? Yeah? Okay, that's actually very good. That's actually very good. Okay, I was not expecting that, but okay. Nice, I love it. Okay, so for the internet, just 2 weeks ago, and it was very significant that they remembered it. So, yeah, it's not that common anymore. Okay, so which one of these three, so Googling, brute forcing, and this search in the database, will give you most data? What do you think? Okay, come on. Like, one of them is, okay, we are Googling for it, so there's kind of like a limited set of things. Brute force, that, okay, will give you a lot of stuff, but it takes a lot of time. And then there's this huge database of HTTPS certificates, where, by the way, HTTPS certificate always have a domain inside it. So which one of these three is the good place where to start? Okay, internet? Yeah, I hope. Internet? That is internet thing, I think. Oh, maybe we have a delay. Anyway, so I think that is the third one, because it's a huge database of everything there is. Okay. Of course, you can always Google. You can always try brute forcing. But Certificate Transparency Project is absolutely amazing for finding subdomains of a domain. So, for example, I will show you what our company is doing. It's this. So, essentially, give me all domains there are for ČVUT.cz. And we as a ČVUT have 34,000 subdomains of ČVUT. And this is all coming from the Certificate Transparency Project. So without any brute forcing or anything, we just got like, I don't know, 34,000 possible targets when running a pen test. What's kind of interesting is that it's also a very good source of emails. Do you know why? You can even find emails in the Certificate Transparency Project. Why? Any ideas why there might be emails in some certificates? Okay, if they load, I can show you. Sorry?
Someone on the internet is typing.
Someone on the internet is typing. Yay! Oh, look at that. So many people. Centrum, Rosino, Ladislav Salvet, Václav Snášel. So what is that? Yes? Exactly, personal certificate for the people. Because when you sign an email, you sign it with a certificate, right? So this certificate ends up here. That's not great. Or at least I think it's not great. I mean, I don't want my email to have to be here. But hey, Česká pošta, right? So that's great. All right. So one more thing, automating discovery. So you don't really have to search through the database. You don't have to go to CertSH or to reconwave.com to find stuff. We installed Asset Finder, which is a tool that allows you to do it automatically inside your containers. So please go to your container. Oh, what is happening? I need to go to my container. Yes. And I run Asset Finder. I don't know what domain. Do we want fel? Okay, we want fel ČVUT. Oh, so many domains. How many? 260. Not bad. What if we do ČVUT.cz? How long is it gonna take? Yeah, it's probably a lot. 34,000. Yeah, 34,000 is gonna take a lot. But this tool is like very helpful. It accesses exactly that. It accesses cert.sh. It accesses something similar to ReconWave, and it finds everything there is about a domain. So it essentially gives you all the subdomains that you would ever need. I'm gonna cancel this because it would take a lot of time. And we have to go a bit further. So we covered subdomains part, right? But how about, so we would find if you would deploy gitlab.mycompany.com, okay? And we would find it. How about if you buy a separate domain for GitLab? So you would buy, I don't know, gitlab.mycompany2.com. How can we find it? Do you think it's possible? And what we are doing here is finding another Apex domain or a root domain where like Apex domain is the domain without a subdomain, right? So it's example.com or actually example.co.uk because you cannot buy co.uk. Okay, so how can you find? Yes. We can try. This is good. Essentially, what you are also saying is because there's a whois. A whois is gonna tell you, okay, who owns this resource, who owns this domain, right? So we can check, okay, who owns google.com? Yeah, we will get a lot of information about google.com, whois server, blah, 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 that Google LLC owns the domain. But the thing is, this registry is very often anonymized. So for example, if I try to search for owner of reconwave.com, we will get data redacted, data redacted, data redacted. Oh, actually they know we are in Prague. That's interesting. And it's Cloudflare. Actually, as far as I can tell, like, people are probably in Prague, but everything else is redacted and they have no idea who that is. So you cannot always do that. But it's definitely a great way how to try it, because for example, in Czechia, the whois registry is by law open. So if you own Czech domain, you are always inside this registry. Yes. Mm-hmm. We can do the guessing, definitely. Yes. So essentially, by the way, what's your name? Hey, how? Sorry. Georgi. Oh, okay, cool. What Georgi is saying is that if we know enough about you, we can do smart guessing. We can Google for you. We can combine all these public information to try figure out what another domain would you buy. That's yes. That's. Yes. Yeah, we can guess. It's yeah, it's actually easy because the only thing that you need for company email to guess is to find one, because usually the companies have the same format how to create email addresses, right? So if you find one, and usually I don't know, CEO's email is public, right? So you find one, then you just replace name, surname, bam, I have your email. And this smart guessing can be part also of finding like additional Apex domains, but we can be a bit smarter. And yeah, as I said, like ideally do whois, but the problem with whois that is anonymized in most of the world. In Czechia, it's not, so you can check who actually owns which domains. But what you can also do is to query the name servers and check who is operating what. So for example, this way, you can find out that, okay, Seznam's name server is this one. And they also operate, and for Novinky is the same one, right? A name server is a server that is responsible for the domain. So it's essentially, if any name server on the world does not know where Seznam is, this server goes to the name server of Seznam.cz and asks him, hey, where Seznam.cz is, right? So this way, to figure out where or which name server is responsible for which domain, you can find out more about the company as well. So you can essentially query, hey, what are all domains that have this particular name server? This is a bit advanced topic, so I will leave it as that. Please, if you have any questions, let us know. We can discuss it into depth because this is very cool and this is what we do in the company with Martin as well. All right, so we found all the domains right now, right? We saw, okay, ČVUT has these domains. We found more about how we can find more root domains or how we can figure out where application runs on the domain level. But how about with paths? Because we said that you can deploy your application behind a path, right? You can have mycompany.com/GitLab. The problem with paths is that, yeah, there's no path transparency project. You don't really have to have the path anywhere. So only thing that we actually have is brute forcing. We can be smart. We can find on the internet like a different, I don't know, list of most commonly used paths, or we can build one for a specific company that we are pen testing or that we are probing. But in general, it's just about brute forcing. So I prepared one example inside your containers. So please go to the container and run this command. It's using GoBuster. GoBuster is a tool written in Go that is essentially doing this enumeration. This is dir mode, which means, okay, try directories. And let's run it on bsi.com. Please, before running it, like make sure you are inside the container, okay? Because inside the container, we redirected bsi.com to one of our services. But if you run it inside container, it's gonna find some real things. Oh wow, that was really fast. That was really fast. Are you able to run GoBuster? Okay, so what can you tell me about the output? What did we find? We found some redirects, right? There's 301, 301 to example.com. I don't know, if I go to example.com, it's probably, yeah, there's nothing really interesting. This one is kind of interesting, right? Because it's another subdomain that we found that was like redirected from /real. There's a YouTube video. Can you guess what the video is? I think you can. There's also another application that runs here, right? It's called Juice. So this is kind of useful, right? Because you get your domain, you figure out, okay, what are like paths, or at least the paths that can be guessed. So we can check. By the way, this one is an application where Martin found vulnerability a week ago. It was used by thousands of people. So if you want to play with it, please be my guest. It's running on your localhost 8080. And please do it after class because we will be not using it. We will not be using it here. But this is a real example that happened 2 weeks ago that is exploitable with one of the things that we will show you in the class today. All right, but we are more interested in the app.bsi.com. So again, I can explore what's there. And there's some HTML, and yay, it's the Avast Juice shop that we talked about. So this is essentially how we found the app. You can find a lot of apps on the internet exactly like this way. It's the same. But for today, this is a synthetic thing. We want to exploit in a safe environment where it's allowed and where it's legal. Okay? So, now please go to your localhost, as we did before, and make sure that you see the same thing as I do. Because we will go and start actually exploiting. Okay? Because we found the application. Nice. Right now, what we can do, or we have to do, is to analyze how the application works. Okay? So we need to figure it out. What are all the inputs, outputs? Where do they display anything that we write? What API are they using? Are they using REST? Are they using something else? Cookies. Are they using cookies? Or what are they doing with parameters? Or essentially anything that we can find about the application. Okay? So first thing first, what we are going to do is to enable netlog or net export in the Google Chrome. If you have Firefox, there's also about networking or about logging, but I will show this in a Chrome-based browser. I'm using Brave, but it doesn't really matter. Whatever that is Chrome-based will work. So if you go to net export, please click on strip private information and start logging to disk. What it's doing right now,
Sorry,
it's
can you repeat that part again? How you got there?
Yes. Okay. So I copy pasted this Chrome net export. Okay, and I put it into my browser like that, like a URL. Okay, and okay, I will show you again. And essentially, I will get this screen that says capture network log. Okay, are you able to do that? Were you able to start logging? So what it's doing is that it's recording all the interactions that your browser is doing. This is super useful because it lets you like record the session on what are you about to do, and it's gonna tell you everything about the application that you are using. Okay, this is not the best tool there is for this task. We will talk about more advanced things later next week in the advanced web attacks class. But this is something that's like so basic that everybody can like use super easily. Okay. Yep, here's a screenshot how to do it. And right now, let's go to this juice shop. And please open your DevTools or your web developer tools. On Chrome, it's F12. I think on Firefox is something like Ctrl-I or Ctrl-Shift-I or something like that. Can you see DevTools, like in your computer? Cool. Because are you familiar with it? By the way, have you used like web tools or web developer tools? Yes, mostly yes. Cool, awesome. Because it's super useful. Because this way, we can see how the browser interacts with what we do right now, right? So if I click here, like what happens? I can see there was whoami request. I can, yeah, right? Because here's the URL. I'm not sure if I can make it bigger. Yay, I can make it bigger, nice. So I can see there was a whoami request with a preview with no user, which probably means I'm not authenticated. There are some reviews. Okay, Curl REST product 1 reviews. So I will make a wild guess and I will say that this is a product number 1 or with ID number 1 because the APIs are usually built like that. You put a parameter into the URL. And what's data? Okay, probably some admin at Juice Shop created this. One of my favorites. Oh, it's review. Yeah, it's here. So one of my favorites. Yeah, that's what admin Juice Shop wrote about this. Cool. So right now what we did was that we discovered like our first REST endpoint. That's good. So we know that there's something like that. Cool. And actually, we also know that whenever you write a review, it gets displayed in here. So this is user-generated content that was just displayed.
Everyone knows what REST is. Remember to stop us, right? Like if Lukasz is going over content and you don't get it, like you just ask, okay?
Yes.
You can also ask in the chat.
Yes, that also works. So first one, okay, can we click here? No. When we are exploring the application, it's just, I don't know, random clicking. It can be random clicking. We can go and find, we can do wild stuff that you want to do. Like you can do essentially anything. The goal here is to map as much as possible and to learn as much as possible about the web application that we are trying to test, okay? So again, some reviews, something, yeah, we are getting the same endpoints. We can check if, yes, the ID is changing. So cool, we are able to see what is happening here. That's very nice. We probably know that, okay, data here, like the response are the reviews. This is review number 1, again, like some author. So we can see, okay, there are users like this. So we now know what users there are inside the application. We don't know the whole list, but we know something, right? Okay, some pagination. Does something change? No, it just loads more stuff, but there's no other things. Okay, images, not interesting. Maybe something more. I don't know. Okay, so what else? Oh, we have search. So, I don't know, Apple. Ooh, nice. We have new things here. You see? Who am I? We saw that one. Reviews, we saw that one. There is a new one. That's search with query parameter. Okay. So this might be really interesting as we go, because right now we discovered, okay, this application is using this query parameter to search for things. Okay. What's the output? Oh, cool. So if we search without like this query, it's gonna give us everything there is. There's also good to know and note. What else? Yeah, pages like this. I don't know. What if I do orange? Is it the same? Yeah, they didn't search. Okay. Login. Cool. Hello world. Okay. Cool.
I will comment while you're doing that.
Yes.
So what Lukasz is trying to do, remember that the panel on the side is giving us all the stuff that we are finding, so but it doesn't appear automatically. So when you see him clicking, it's like him trying to actually discover all the content on the website, so we can discover all the resources, all the pages that are being loaded, and then we have like a nice list, right? So this is what you want to do at the beginning, just to make sure that you have the complete picture of what the website has before you start focusing on something going super deep.
Exactly.
Yeah?
We need to first map what is the application doing, and then we can try to find vulnerabilities. Okay. So here we can see, okay, we discovered another endpoint, which is like REST user login with these parameters. Like, this is cool. This is awesome. So how about some registration? Can I register? Okay. Can I register? I don't know. Okay. Please do not show. Register. Hey, okay. There was a post on API users. Cool. Another API, another endpoint. What else? Customer feedback. As an anonymous. Okay, CAPTCHA. Oh my god. Why is there a CAPTCHA then? Oh wow. By the way, another endpoint. Okay. They are loading CAPTCHAs from the backend. Answer 10. Oh wow, they are leaking answers. That also does not look really safe, right? CAPTCHA ID, okay, cool. CAPTCHA, right, fine. So, wait, how come that I cannot, I have to give rating. Cool, another one, okay. Feedbacks, okay, this is a post on API feedbacks with this payload. Okay, you know, another endpoint. How about this? If I click, oh wow, this is actually my input, right? This is what I wrote there. So mental note, this is another thing where they display user content. And yeah, hey, there's an endpoint for that. Cool. So how about anything else? Photo wall. Okay, another endpoint with memories, good to know. And that's basically it. Yeah, I guess this is it. Okay, so right now we went through the whole application that we have access to right now. Okay, any questions so far? What we are doing? Or anything to DevTools, anything to the application? No? All good? Cool. So we were just clicking, and now back to the file, because we generated the file. Remember, we did network export from net export like this one. So we can go. I created already a pre-exported file for you, so you can analyze it in your Dockers. But essentially, what it does is that it recorded all the interactions that we had. Okay. So you can see that, okay, there are these images. Oh, we access these endpoints. That's cool. Oh, wow, security answer. I didn't see security answer in the web tool, but maybe I just missed it, you know, because there are like so many requests going on all the time when I do something. So this is why I recommend like starting this export, so you can actually see what did you miss. So we found challenges, feedbacks, quantity, security answers, security questions, API users. What's there? Assets. I don't think that we care too much about assets. Oh, this is a weird asset. Redirects. Okay, yeah, this is when I clicked on GitHub. Oh, application configuration, application version, CAPTCHAs. You see? So, as I said earlier, the idea is to figure out as much about application as we can. And we are focusing on user inputs, places where they display user-generated content, and also like API or the endpoints that they are using, and the format that they are using. Okay, because this way we have places where we can focus on when we start exploitation. Okay? Yes. For slash. Okay, so let me rephrase. Georgi thinks that it's faster to search for endpoints just by searching for slashes in JavaScript. That's definitely true. That's also part of the reconnaissance or like exploring how does the application works. Because a lot of time, because in like many instances, like people simply hard code the endpoints inside the JavaScript. Like that's definitely right. Sometimes they do not. Sometimes they are loaded from the server, depending on the configuration. And at that point, you will not find them because they are somehow somewhere hidden. But it's definite that's a great point. Like definitely, like analyzing the source code of web application is also a way how to find more stuff about how it works. Any questions? Nope. All right. Cool. So as I said earlier, this is like very naive and like simple interaction logging. In the advanced class, we will talk about Burp and maybe Kaido, which are like proxies that actually, or advanced hacking tools that allows you to modify the interactions and record them as you go. Please go back to export to the Chrome export and disable the logging, because otherwise it's like doing a lot of stuff, right? So I don't know, yeah, like this. And now it's not logging. Cool. So just to recap what we did right now is that before you start actually finding any vulnerabilities, or before you can try, you need to find like all running applications. You need to find everything there is about your target. Okay, that's the doing reconnaissance. And applications are usually deployed under new subdomains or paths. Subdomains can be found by querying the certificate transparency project, or by brute forcing, or you can use the asset finder or any other tools there are. Paths sadly must be brute forced or crawled if you are using, I don't know, something like Puppeteer or any browser automation that can find stuff. And when you find running applications, your analysis should focus on mapping all the interactions, user inputs, user outputs, anything that displays user-generated content, API endpoints, and like in general, complete behavior, how the application works. And if you have time, also analyze the source code, because that one is like really fun. Okay? Any questions for the application analysis, for how to find new applications or how to find stuff on the internet or anything? No? Internet? Are there any questions on the internet? No? All right, so let's have a first break for 10 minutes and we will be back at, 15:45. Shall we? Cool. Okay, now we are on. Cool. All right, so we are starting now. Okay, I got some really nice message here. Cool. Next part is going to be a bit more theoretical. We will talk about like top most common vulnerabilities or types of vulnerabilities there are on the web. There's an organization called OWASP that is doing all the research and all the vulnerability evidence, I guess, on the web, and they make this nice list of two of like the most common vulnerabilities there are. So right now we will go through all of the types that we have, and then we will practically exploit two of them in the following sections. So first one, broken access control. Broken access control is essentially that your application does not check user rights properly. So, for example, it allows you to access data that you shouldn't be able to access. This one is like most common thing there is, and I don't know, it's probably very hard to fix, mitigate, or anything, and the only advice I have for you is to, I don't know, like check what your users are accessing. Like this is a software engineering issue, not really, and this cannot be fixed by like applying any outside like web application firewalls or anything like that. This is really a bug in a software that people wrote that allows them to access things that they shouldn't have access to. For example, a little for discussion. In the OWASP Juice Shop, we saw that IDs of products or reviews have integer ID. Okay, so they have 1, 2, 3, 4, 5. What does this tell you? Or what can you imagine that your attack vector would be if you know that IDs are integers and are incremented by 1? For example, can you fetch all the reviews, all the products there are? Right? Yes, you can, right? You just try curl 1, curl 2, curl 3. So you can iterate over the whole set until you get 404, not found, and then, okay, like there are all these products. So this can be one of them. I mean, this can be also like a broken access control, because if you don't check that this user has access to this product, hey, you get vulnerability. How about if your IDs in the database are UIDs, so unique identifier or something, I don't know the name. Like, you know, the thing like this thing. What if your IDs are like this? Right? It's better. This is better. I mean, even if you have a bug that does not check if your user has access to this particular ID, you can still kind of live without it. I'm not telling you to do it, but what I'm saying is this sort of mitigates problems with enumeration of IDs. So please, if you can, use UIDs in your databases. Next one. Yes, sorry. Mm-hmm. Yes. Yes. Yeah, I made a bad example. So with products, yes. If this is a resource you want to show to everyone, definitely. If this is thing like user document or anything that should stay private, then UIDs are probably a bit better in the terms that, you know, you cannot enumerate over them. Well, You sort of can, but there are more UIDs than particles in the universe, so good luck with that. Any other question for broken access control? Cool. Moving to next one, cryptographic failures. So the problem here is that, or it's defined as a failure to properly set, define, and enforce all the encryption, hashing, privacy settings, certificates, and everything for the data that is needed. That also includes law, GDPR and stuff. You should have your stuff encrypted. But in general, what it means is that developers do make mistakes when implementing encryption and hashing. Do you know the difference between encryption and hashing? Anyone? Yes? Can you tell me the... Yeah, we have Mandos. By the way, we have Mandos. Hey, okay, if you tell it. Okay. Okay. Can you retrieve whatever was? Yeah. Sorry. I'll just repeat it. What's your name, by the way? Hey, Vlad. So what Vlad was saying is that you would use encryption for something like peer-to-peer communication, HTTPS, and whatnot. And hashing is when you want to hide something, right? And my follow-up question is: can you retrieve data that were hashed? That was hashed? Exactly, exactly. You cannot. Hey, by the way, hop. Oh, shit. Sorry. Sorry. So the difference between encryption and hashing is that hashing is only one way. You cannot retrieve data that were hashed. You can retrieve data that were encrypted, given that you have the key to need to unlock the data. So cryptographic failures here are usually related to developers not signing their tokens, not encrypting user data, and generally mishandling how the encryption works. By the way, very recent thing that happened a few weeks ago. Do you know about Auth0, or was it Okta? Okta? I think it was Auth0. It doesn't matter. Do you know who Okta is? Okay, Okta is one of the biggest companies there is on the world that is doing just authentication. Like, they're literally their job is, okay, I give you authentication as a service, and I will manage your users for you. So, you know, everybody will log in at my site, and I will just tell you, okay, these guys are logged in, and this is their information, you know. So, from the way I see it, like, these guys should be the ones that are the best in the world in hashing, encryption, whatever, and they should know what they are building, right? So they had a vulnerability 2-3 weeks ago where they mishandled how they are hashing passwords. Okay, so the only company on the world that is doing, hey, we know that you will not do it right, we will do it right. Yeah, they did not. So hashing, encryption is hard. It's the second, you know, most problematic thing there is on the world in software engineering. So, you know, make sure that you're using standard libraries for encryption and hashing. Make sure you are using them right. Make sure to read the manual or the documentation on how to use them. Okay?
And do not roll your own crypto.
And do not, exactly, do not roll your own crypto.
We have a question from the internet.
Yes.
Probably it's too broad, but how cryptographic failures can be exploited?
How cryptographic failures can be exploited. So in case, in general, it depends. In case of Okta, that was that if your username was longer than 52 characters. That's kind of like, okay, that's user input, right? That's user input. But in general, it really depends. If you do not, for example, if you do not sign your tokens, you can just craft your own token, right? And just send it and they will accept it. That's a cryptographic failure in not checking the signatures correctly. Or, I don't know. Another one is if you do not encrypt your database and you find like another vulnerability, then you can read all the data there are inside the database. Hey, do you want like anybody to, I don't know, read your photos in Google Cloud or anything like that? I mean, you do not want to, right? So that's also a thing. Then there are like more advanced types of attacks on encryption that are usually using some sort of side channel, which is like, so they are not directly targeting the cipher or the algorithm, but they are trying to observe, for example, how long something takes. So you are observing the environment where the encryption is supposed to happen, or anything like that. There are like so many different things how to exploit cryptography. All right. Any questions for cryptography? Failures? No? Cool. Moving on. Injection. Again, real case. Did you see this? This happened 2 days before I was teaching class last year. So somebody injected their own code into COS, replaced the logo for Pornhub. That was fun. That was great. So injection problems are failures to validate or sanitize user input. It's always user input that allows malicious data to exploit dynamic queries, commands, and whatever you are running on the server that leads to unauthorized access or data exposure. So in this case, some student was able to inject their own JavaScript inside COS, which resulted in in pretty much this. It was awesome. I mean, there were also people like chatting and showing rickrolls and like everything going on. So that was great. I hope that it was fixed, but let's see. Please, Chevauta does not have a bug bounty program, so please do not try to do that. This is like very illegal. I don't think if something happened, but like, okay, let's leave it like that. And into this category, there's a cross-site scripting and SQL injection. Cross-site scripting is like injecting JavaScript inside the browser, inside the code of the website. And SQL injection is like injecting SQL inside the queries that the server is doing. We will explore these two in more detail in this class. Then there's insecure design. It's sort of like a generic category that essentially covers that when the people were designing the application, they did not really think about what they are doing, and they did not do the threat modeling, or they didn't consider what are actually the threats of this application. Then there's security misconfiguration. Typically, when you, for example, do not enable your firewall, when you, I don't know, leave admin as a password, you essentially just leave the component as is, or you do not configure it properly. Another one is using vulnerable and outdated components. So please update your libraries and update your systems, update your browsers, and update everything that you can, because this essentially includes like everything. So please do update. Another one is identification and authentication failures. This is very much related to the cryptography, but this one is more about weak authentication and session management. So, for example, if your system is vulnerable to password brute forcing, this is the one. So, you know, when you are designing your application, please add, I don't know, timeout for passwords. Do you have rate limits? Have something in order to slow down attackers trying to break into your application. The 9th one is security logging and monitoring failures. This one is essentially about people not having their monitoring set up, that they are not monitoring logs. Yeah, this one is not really about defense, but more about actually figuring out that you were breached, or when you are investigating the incident, what actually happened. So it's good to log access, who is accessing what, and log everything that is happening inside your application. And last one is server-side request forgery. So that one is about when user-supplied URLs are not validated. and it essentially allows attacker to manipulate a request to force your server to go to different URLs, to unauthenticated servers, to places where they can fetch data and stuff like that. So for example, if I can force your server to go to my URL and download, for example, an image, then I can force your server to download a file that has, I don't know, terabytes of data. Okay, so this one is also like very dangerous on the server side. We will talk about this one next week in advanced classes. All right. Any question for OWASP Top 10? Nope. All right. So let's start exploiting. Yes, internet.
Internet is asking, is there a fail to ban for web apps?
Is there a fail to ban for web apps? Yes, there is. It's called Web Application Framework, and we will talk about it a bit more in the mitigation part of the class. We'll probably talk about it next week, not this one. But fail to ban for web applications, there definitely is. Also, Cloudflare is doing that in with their protection and whatever. So we will talk about it. All right, so let's go to cross-site scripting. Cross-site scripting is a vulnerability that allows an attacker to inject malicious scripts into web pages viewed by other users. Okay, so what it essentially means is that I, as an attacker, can force you, as a user, to execute my JavaScript. Okay? The thing is, this JavaScript executes in your browser, in victim's browser. So I can modify any content you see. I can modify the static content that is generated by the server. I can do actions in the name of the victim. So I can, for example, I don't know, create a new product. I can place an order in a hash shop, for example, or I can do virtually anything that you as a user can do. Okay? I can also exfiltrate data from the site. So I, as an attacker, can see what you as a victim is doing. I can see what data you see. I can act in your name, essentially. The thing that I cannot do is to access your local computer. Okay, and I cannot access the data from different sites. So, for example, I cannot see what you are writing on your Facebook. Okay, cross-site scripting is always tied to the same origin. Same origin as a triple. It's a scheme, host, and port. So I can see. So HTTP example.com is one origin. HTTPS example.com is a different one, and HTTP example 8080 is also a different one. So if I'm able to exploit this site, I cannot exploit the other two. Okay? Or I cannot read the content of the other two. Okay? This is something called same origin policy. I think I put a link somewhere, or I will put definitely later. It's a way how browsers protect us exactly against this. Okay? So if some vulnerable website written by I don't know who is vulnerable, it does not compromise the security of other websites, of, for example, Facebook.com or anything else. Okay? But the key learning here is that if I, as an attacker, can execute JavaScript inside your browser, I can act as you inside the browser, and I can change what you see, and I can see what you do. Okay? So, for example, if that website is operating your bank account, I can now operate your bank account. Okay? And that's why this is like very, very important and very, very good like exploit and very critical vulnerability. All right? Yes. Here's the link. The reason why this happens is always kind of the same, and it's the problem. It's possible because of the incorrect input sanitization on the server client side. Doesn't matter, but the application is not properly sanitizing inputs. Okay, so I can actually like inject JavaScript into something that's supposed to be, I don't know, name, email, or anything like that. If you are using frameworks for development, so for example, React or, I don't know, Vue, Svelte, or something like that, they usually force you, or they usually try to tell you, hey, this is not the way how to do it. So there's, for example, in React, the only way how to actually insert HTML is like dangerously set in HTML. Like, you know, if you see something like that in your code, you should realize, hey, this is probably not the way how to do it. Okay? So this is why they kind of try to force you not to do it, but I mean, there's nothing preventing you from actually writing that. All right, so how does cross-site scripting work? So consider this like super simple HTML, right? This can be, I don't know, part of the registration page or something, where we have welcome johndoe.com, right? And this is some sort of user-generated code or user-generated input, right? Like usually it is, because like how would they know your email, right? They have to get it somehow. So what if instead of John Doe, we pass like this part? So we are passing like a valid HTML, right? What happens is that the generated HTML will look like this, and it means that H1, what is H1 by the way? Do you know what is H1? Yeah, exactly. It's just like a, you know, make the font larger, or it's header 1 or something like that. So your client gets this HTML and sees, okay, there's H1, welcome, span, okay, again, H1. So this is probably a mistake. Should have been H2, I don't know, it doesn't matter. But the thing is, they will interpret this as a valid HTML, right? They do not know that this is user-generated content. They just know, hey, server sent me this HTML, I need to interpret it, so I will display it the way that it's written here. What you are doing here is that you are like literally modifying the page that the user sees. But that's kind of it. Like, this is not the interesting part, right? Because it's just some HTML, you change it how it looks, not a big deal, really. But what if we are able to inject JavaScript like that? Because if instead of H1, we are injecting JavaScript, then the fun starts, right? Because with JavaScript, we can do anything. We can exfiltrate data, we can access stuff, we can see what the people are doing. Well, you can, I don't know, you can mine crypto if you want to in the browser of your victim, right? So whenever browser renders this page, like this JavaScript would get executed, and the person would get the alert. So let's try this, okay? The thing is, it's not that simple, but let's try. So I prepared a simple HTML for you. It's this one. You can also download it here, or you copy paste it. Doesn't matter. How do I download it, by the way? Ah, yes. Yes, replace. So this is the HTML that we are looking on, right? It's it looks like this, and there's a simple input. Hey, my name is Lucas Forst. Okay. Hi. What is happening here is that you have some JavaScript. That what it does is that it takes. Oh, why is it not formatted right? Let me. Oh, damn it. Let me format it right. What it's doing is that there's an input. Whenever there's a input happening, so whenever you type new character, this JavaScript function gets executed, which is this one. So what this one is doing is like document get element name input. So we take the value of this field of the input. So this is the field, right? This is what we are reading with our function, and we will put it here into this span. and that's like document get element, display name, this one, inner HTML. Okay, so we are essentially taking whatever the user writes here, and we are putting it here in the span. So, what if instead of writing, my name, what if I try to put HTML? Oh, wow. So we essentially got HTML editor. That's nice. And we said that if I write script, something happens, right? Yeah. So it does not work. The cool thing is, this worked, I don't know, 3 years ago, 4 years ago, maybe. Because browsers are kind of smart nowadays and will not allow you to simply write like this, so to simply like execute the script that's inside the HTML. If I go here and check the generated HTML, I can see that this is valid, right? This would normally get executed and it's fine, and I would get an alert. But this is no longer working because of some browser security update. There's a whole explanation that I put on the in here that says that inner HTML can no longer execute JavaScript. But what if instead of inserting directly script in JavaScript like that, what if we insert HTML element that under some conditions execute JavaScript? Is that possible? Because if you look here, this is an HTML element that has event on input that whenever you write something, it executes like this JavaScript inside, right? So you can effectively force browser to execute JavaScript even without like directly injecting the script directive, right? For this, I prepared an example with image, okay? This one is essentially create image whose source is current website, which does not have an image. And if you fail to fetch content, execute this JavaScript, right? So if I put it here to my website and I write image source does not exist, on error, hacked. Okay, did I do some mistake? Why it does not work? Yay! You see? So you can force browser, even after this update, I mean, you can force them to execute your JavaScript in different parts of the HTML. Okay? And now, when you are able to execute JavaScript, you can do anything. Okay? String complete language and everything, so you can just like...
Does it work for you?
Yes. Does it work for you?
I want screenshots in the chat. Evidence.
Nice.
You're too quiet today. We want more questions. More tries.
All right. So does anyone know how to fix this HTML form? Yes. Yes, exactly. Yay! You deserve this one. Sorry. Oh my God! I was close this time. I was pretty close. Exactly. So what you would do is like replace it with text content, where you are essentially saying browser, hey, this is not to be interpreted. This one is like simply text, so display it as a text. There are two types of cross-site scripting. One of them is reflected, and the another one is stored. So reflected one is a type of cross-site scripting where malicious scripts are injected into web application and immediately reflected to user, which means that they will get executed exactly at the time when you access the website. So attacker typically has to like put the malicious code or malicious JavaScript inside the URL where you click. okay? Because there's no storage involved. You click, you get a website, JavaScript gets executed, and you know, like attacker just hacked you or took over your website. Another one is stored. Stored is when the malicious code gets stored on the server, usually in some database, and is retrieved when the user accesses data that contains the code. Okay? So this happens, for example, if you are able to exploit user reviews, right? And you put script alert, so whoever accesses this user review gets the alert. Okay? So which one of these two is more dangerous? Like, which one of these two do you think is more dangerous? Yeah? Exactly. Because you as a user, I mean, if you get a link where you see there's a JavaScript or some weird things, you say, I'm not going to click on this, right? But if you are inside the application and you click on, okay, I trust that when I click on reviews, it's fine, right? I want to see reviews. So I click on reviews and somebody actually hacks me. Wow, that's pretty bad. Okay? Okay, so let's go to Juice Shop, and we will try to exploit the Juice Shop. When we were doing a reconnaissance, we saw that I can search, right? And whenever I search, whatever I put here ends up here. So, I don't know. Hello, world. Oh, there's actually Juice Shop Permafrost Edition. Cool. And this is the user-generated content that I can inject here, but it also persists in the URL. So whenever I search for hello, it's inside the URL. And it also works the other way. If I put here world, it shows here. So I put BSI, I get BSI over here. What if we can test like very easily if this is vulnerable to XSS? Again, we put like this and say hello. Oh, it does not look different. How about this? Oh, okay, something happened. Right? It moved. So what if I try something different? We already established that this one is not going to work because of the browsers, right? But what if I try the example with the images before? So on error, I'll write alert. I don't know, I will not. Ooh, cool. So we can execute JavaScript like this. But it's not very interesting if I'm able to execute JavaScript while I am searching, right? I mean, I can exploit myself, but like, why, right? Why would I do that? The thing that is really important here is that they store this payload inside the URL. So I can simply like copy this, send it to somebody else, and it gets executed. So I can send you the URL, I can hack you. Okay? And this is the reflected cross-site scripting when I can like insert payload inside the URL and send it to you. Okay? And whenever I can execute JavaScript, I can do like anything, like, right? And yeah, you can see it like the example that goes directly into the URL. These payloads, there are so many of them that you can use. Like I linked also a list of very useful payloads. By the way, there's also one payload that's called Polymorph that is also like a cross-site scripting payload. So it can inject JavaScript, but it can also do SQL injection at once. So it's like kind of crazy thing down there. So go and see. Another version of the cross-site scripting is the one that's kind of blind, that you don't see the result directly. Because if I send you a link and then you probably click on it, you kind of know that this is going to happen, it's okay. But the blind one is more interesting because what if you cannot see the user output? So for example, I don't know, You write a review for a doctor, and you cannot see the review. Only the doctor can see it, right? So, but what if this is exploitable? So what if you can exploit when they display this review, but you cannot see it, so you cannot test it. So that's why it's called blind. You are essentially shooting into dark and you don't know. So how do you test it? How do you verify something that you cannot see? Okay, any ideas? How? Just Google. Okay, that's good. I like it. I mean, you would probably Google how to do it, so that's good. Or you would ChatGPT for it. Is that a word, ChatGPT for it? I think it is. There are tools that allows you to record any interaction with themselves. So essentially, have you ever heard word canary token? Canary token is data. It can be, sorry? Really? Oh, nice. Then you didn't tell me. Okay. Anyway, canary tokens, you know all about them because you had it in class. It essentially allows you to record that somebody had an interaction with them. So imagine this as a URL that somebody accessed, so you can check that somebody actually accessed that. We can use exactly the same thing here, and we can check what happens. So I choose one. There are like many of them, but this one is like very nice. So please go here, go to appinterrush.com. It's gonna generate URL for you. It's this one. Please do not access it. It's just like copy it. We will need it a bit later. So copy it. Then it generated you a domain that looks something like that. Now we will have to execute some JavaScript. So we have to choose payload. I really like this image. So we use this one, and we want to demonstrate that what we are doing is actually accessing the URL, right? So we can download, I don't know, more JavaScript. We can exfiltrate the data. We can post stuff there. I don't know, go wild with whatever you want to, right? So we will use fetch for that. We need to put URL here. So the final payload looks like this. So if I go here and I write fetch, okay, I copied this one. So I replace it with the one that I just copied. And by the way, this one is still empty, okay? I put it here. Hopefully it's gonna work. Okay, I don't see anything because I didn't do any alert. But my interaction tool just showed me that, oh my God, so many interactions. So somebody did DNS, somebody tried to resolve this domain. I can I can see the source. I can see the source, so this one. Again, some DNS. Oh, there was some HTTP. So somebody tried to access this domain. I can see that they came from the juice shop Heroku. Okay, somebody is using the official instance, cool. They are using Macintosh. Oh, that's actually me. No, it's not me. No, it's not me. What else? Yeah, IP address. This is the one. So this is IP address from ČVUT. So it's somebody from here. It happens like this. Or another one. Oh wow, this is another guy. Again, cool. Intel Mac. Oh, it's an Intel Mac. Wow. So many interactions. So the point here is that you can use tools like this to record somebody else's interactions with your XSS, with your cross-site scripting. So this way you can see that the code actually got executed, and that some field is vulnerable to cross-site scripting. And by the way, this will be like enough as a proof. Okay, it actually is vulnerable. There are other tools like this that even craft your payloads for you with included URLs. You can put nodes, whatever. But this one is just like, it's available on the internet, so I showed this one, and we can see like what people are doing like this. Okay, so if I sent you a link that looks like this, please do not click on it. It's probably a very bad idea to click on links that include like JavaScript.
But it's fun.
It's colors, right? You mean o's.fun. Okay, another thing. If you are an administrator of your company system and you see domain o's.fun, people were not having fun, okay, when accessing this. So not a good idea. Actually, I was trying that when I was sitting in a bank because our company has offices in a bank, in one of the banks, and they did not allow me to actually go to this website. So, yep. And questions for cross-site scripting? Anything that you want to talk about that you did not understand, that you didn't see, or anything like that? Please, whenever you accept user-generated content and you want to display it, you need to sanitize it or escape it. Okay? Okay, cool. One more thing. If you go to localhost 8080, there's this running application by Levels EO. I don't know if you know the guy, but he's very famous on Twitter. He's doing lots of cool stuff. And this was the application that like thousands of people were using it. So if you can, try to exploit it during the break. But right now we have a 10 minutes break. Cool. Thank you. Okay, people. So we are starting again. There was a question on the internet if, as a Recon Wave, have an API. We do not. We want to. We will build one. Yet, exactly. And also, if we give you a premium plan for free, we will. Let us know, right? You know, give us your email or how you sign up, and we will give you, I don't know, like premium plan for free because it's cool. Yay! This is like 10 euros, you know, 5. I don't know how much we charge. Oh.
I mean, you're saying it to the internet, so there is record, right?
And there's record. Like, if anybody writes us and sees this, you know, references this video and tells us about the secret word that we are about to show, then we will give you a premium of Recon Wave for free. Yeah, also somebody tried to exploit us. That's cool. I love it. That's very cool. All right. Cool. So moving on. SQL injection. So SQL injection. SQL injection is, again, a code injection, the same way as we did with JavaScript, but this time we are injecting SQL. And it's a technique where attacker exploits vulnerabilities in applications SQL query handling to execute unauthorized commands. So again, we are injecting some code. This time it's SQL. This time it's running on the server. So it's actually way more dangerous. Okay? And I know in the past some people told us, yeah, but this is not real, right? I mean, everybody is using ORM frameworks that are actually taking care of that. It's not true. When you search in ExploitDB for SQL, you can see it's like 90% of everything that they are tracking. And the last one is from, yeah, this is nice, 1st of October. Okay, so this is very real problem. Okay, and before we go into the very real problem, I have a thing for the remote students, which is the secret word, and it's ping pong. Okay, ping pong. All right, ping pong. So if you want a premium access for you know, Recon Wave search, write ping pong with your email to us, not on metrics. Please do not spoil the fun, or please do not spoil the secret word. And you know, let us know. We will set you with the premium account. Cool, ping pong. All right. SQL injection. Again, Juice Shop. So let's go back to the Juice Shop. This time we are not exploiting the search, but when we are analyzing the application, we discovered some endpoints. All endpoints are potentially exploitable with the SQL injection. Okay, but right now we will focus on the one that we saw actually first, and that's the login. Okay, so again, open the DevTools, and let's see what is happening when I try to log in. So if I try to, I don't know, hello world, I can see that there is a request going on to login site. With its post, it says unauthorized, which means, okay, yeah, probably user hello world with password 123 does not exist. That's kind of surprising, but okay. And the payload that we sent is this. So this is what the user sends, okay? Email is what I put here. Here I put email, and it ends up here as a parameter. Password is the same, right? Okay. Now, when you are exploiting an application, you need like a lot of creativity to figure it out how everything might work. Okay, so the first thing that you do when you, so for example, imagine you are designing an application, right? And you are doing login. So you need to persist users inside database, and whenever they try to log in, you have to write query that kind of like checks if the user exists and checks if the password is correct, right? So there's probably some SQL going on. When I go here, users are probably stored in some database because you need persistence, whatever. Then you need to kind of think, okay, so if I am designing this, how would I design it? I would probably have some table users with email and password. I'm not sure if I would store passwords in plain text. By the way, quick question. Why is it not a good idea to store passwords in plain text? Which means if I put Pepito123, I will store it as Pepito123. Any thoughts on this? Exactly. If the DB leaks, then all passwords were leaked. Okay? Which means that anybody can log in as anybody. But also what we are doing is we are actually making internet less safe because we just created a new data set of what people are using as passwords. So we actually extended like some, password word lists for attackers to try. Moreover, sadly, users tend to put the same passwords everywhere. So if you have the same password to your Gmail as to my juice shop, it's bad, okay? Because if the database from juice shop leaks and somebody actually tries to exploit your Gmail, yeah, good luck, okay? So 2 learnings. First of all, do not store passwords in plain text. Use hash functions for it. So hash the password before storing it. Second key lesson here is please do not reuse the passwords for online services because you never know which one of them was not implemented properly and which one of them leaked their database. Okay? Cool. So back to our SQL injection. If my table, if my database looks like this, then the query for getting user with email, in this case Pepito, looks like this, right? You do select everything from users where email is email. Yes? That's a very, let's say, personal question, but I think it's always like password manager. Yes, sorry, the question was what is a good way how to store your passwords? The best thing ever is not to have passwords. Sadly, we live in an age where passkeys are not as widespread as they should be. But I think there are like many different ways how to do it. Some people write it on the Post-it note and put it on your computer, so that's not the way how to do it. but I think that password managers are very good. There's also this, how's it called? There's this algorithm that generates password for you based on a seed phrase and a domain of the service. So you actually have a single password, and that's it. Then you put like a name of the domain, and it generates a password for you. But it's like it's doing it all the same time, like same way all the time. So you create your account, you put the same password that this generated for you, and then when you want to log in, you again put like this master password and the domain into this password generator and generates the same password. Okay, that's considered very safe. I would not use it because to me I will probably forget the master password and then I'm screwed. But with the password manager it's the same, so if I ever forgot this password it's probably bad. But I think it really depends on what you want to use, and like it's fun. Yes.
So it's a really complex question, and as Lukasz said, that there is a lot of different solutions depending on the person. But the key important thing here is to evaluate what we call like adversaries in a way, right? Writing a POSIX, it might be bad if you work in a company where your desk is seen by a lot of people. But if you're at home, maybe writing the password is better than reusing the same password everywhere because you cannot remember. So a lot of people is going back to paper because the probability of someone breaking into your place and stealing your notebook with the passwords and using that to access your accounts is like very, very, very rare. So it's safer than having it having the same password everywhere. So it really depends. Password managers, whether they are online or in paper or something, is better than just using your same password everywhere.
Exactly. As Veronica said, it's all about your like threat modeling. So in a way, like what you are afraid the most. Okay. Sorry.
Threat modeling. I forgot the word.
Yeah, it's that. It's threat modeling. So for example, me personally, yes. So that's also like very complicated topic. The problem is that I don't want to say, but but the thing with password and for example police is that police cannot force you to say the password. They cannot force you to give them the password. But fingerprint, hey, like they can actually, because you cannot say, oh, I forgot my fingerprint at home. I don't remember my fingertip. You cannot change it. That's also a problem, right? And you cannot get a password from a dead man, but you kind of can get the finger from a dead man. So yes and no, like again, like depends on your threat model. Are you afraid of police or are you afraid of people like killing you for something? Depends. It's a convenience. Okay. Cool. Passwords. Yeah, that's awesome topic. All right, so going back to the SQL query that we are running for authentication and for selecting people. So essentially, like this is something that I would implement when fetching users from database. So the query would like select everything from the table users where email is Pepito. Okay. In SQL, when we want to write string, we write this. How's it called, this character, by the way? It's a apostrophe. It's an apostrophe. Yeah, it's an apostrophe. So we write apostrophe, right? So what happens if if this user-generated string contains the apostrophe? What happens to the query? Right. So what if we try to log in like that? So I put, I don't know, hello, and I put apostrophe here. I don't know, password again, like the same, hello world. Notice what we are doing here. Okay, this is weird. Why is there error that says object? That's kind of wrong, right? So let's inspect what happened. And we did send this payload. What happened is that we got error that says SQLite error, near word syntax error, SQLized database. Okay, this looks like we just broke the SQL query that is running on a server, right? So what does this tell us? Like this, what does this tell us? Like the error that we just received. Any ideas? Yes, Grigori. Exactly. So just to repeat for the internet, we can see that the application is using SQLite as a database. And in addition to that, we can see the whole query that is doing and executing inside the database. So our guess was kind of good. Just the table name is a bit different. It's users with capital U, where email and password they are doing some hashing. That's good, kind of. And deleted is null. That's nice. Okay, so now we know what they are doing. First of all, the lesson here, apart from the whole SQL injection, is never expose like this information to the user, to the front end. Okay? Because if we have to guess how the query looks like, we are essentially flying blind and we are like hacking something that we don't know how it works. But right now, we just learned how the query looks like. Okay? So how can we weaponize it? Like how can we modify the query in a way that it would let us log in without actually knowing the password? Any ideas if the query looks like this? So select everything from users where email is our user-generated string and password and delete this null. Yes? Exactly. Thank you, Vlad, right? Cool. So I have another one for you because this was exactly the answer I was looking for. So woo, nice, for a third time is the charm. So just to repeat for the internet, what Vlad said is that we can insert like a generic condition that always matches. Okay? And then we don't really care about password and delete it and whatever else. Okay? So if I try to do it, So what you are saying is that we would do something like this. This would, end the string. And then we can do generic condition like, I don't know, like this. Right? Is it something like that? Okay, let's try. Oh, we are still getting some error. So let's check. Quotation mark, one more. One less. Okay, let's try again. Okay. But this time it actually worked. I mean, we didn't get the error, but we did get invalid email or password. Yes. I'm not sure if I can much more. Okay. I think that I can zoom this one though. Yes, I can. So this time, let's get back to a place where we saw the query. So what happened here is hello, we close the query, but there's this still and password something 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 and deleted is at null. But we can get rid of these conditions as well. Do you know? So because SQL is like interpreted language, we can inject whatever we want to, and we can, for example, like inject comments. Okay, so we can actually like comment the rest of the query out, right? So this one is good. So let's try to put, I don't know, how are the comments in SQLite? Okay, this is not the way they are. So let's check here. Is dash dash space dash? Oh, actually we have it here. Okay. Okay. This does not work. Why? That's actually a great question. Why it does not work? Exactly. Yay! We are in, and we didn't know the password. Oh, that's cool, right? So did you try? Can you try inside your own instances? Can you try to log in? You should get this awesome banner. Successfully solved challenge. Yay, they are congratulating us that we are awesome hackers and we just log in without actually knowing anything.
A screenshot or it didn't happen.
Exactly. When doing networking classes, peek up or didn't happen. This time it's screenshot or didn't happen. Okay, so let's just recap what happened. We were exploiting this query where our user-generated input went here. We could not exploit password because password was hashed. So if we try to exploit the password, it wouldn't work because it ran through some hash function. We don't care about this one, but it didn't end up as directly as the user-generated input. Whereas the email, that was completely us. It was up to us what do we put here, right? So what we did is that we essentially put part of the query, we modified it in a way so it always matched because of this part, right? And we commented out the rest of the query. So it didn't interfere with whatever we were doing. Okay? And this gave us the login. So now we can explore more what is doing in here. Oh, we have basket. Nice. We can buy stuff. Can we buy stuff? Yeah, I guess we can. That's cool. Ooh, wow. User profile. Oh, there's gonna be so many cross-site script things. You can go wild if you want to. But okay. Any questions to how this happened? How is it possible that we were able to log in without actually knowing the password? Any questions for the SQL injection? No? Okay, cool. So we were able to log in, so we bypassed something. But we are still able to see only what users are allowed to see. So this time we can do more. We can do basket. We can explore more API. So we can repeat the process that we did at the beginning, where we did the reconnaissance of the web application. But we are now more interested in the whole database because we know that the application is vulnerable. And instead of going through everything and every endpoint and everything there is, we can instead exfiltrate the whole database of the application and read it for ourselves. And this is exactly how we would know all the passwords and everything that the database operates. Okay. For that, what we are going to do is use something that's called union attack, and we will use the query parameter for search again, because we know that this endpoint is using query parameter for search. So for example, if I copy it and I access it like this in my browser, I know that it's returning some JSON with data. I can see products, I can see Apple, blah, 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 stuff. Okay? And if I try to modify the parameter, okay, so let's try to search only for Apple. Right? Okay, so it's actually filtering for products based on the name. Right? If I do orange, okay, I get only orange juice. Now, how would the query look like in this case? Will probably be something different, something kind of similar, right? You would put orange somewhere in the query or the user-generated input. So again, we can verify very quickly if this query is vulnerable to SQLi by injecting our awesome magic car, the apostrophe, like this into the query, and I just run it like this. Oh, wow. So again, it's probably vulnerable. HTTP 500 is not something that we would like to see. If it's okay. So what does this tell us? What can you read from this error message that we just received? Any ideas? Yes. Yes, exactly, exactly. Thank you so much. Oh, you deserve another one. Okay, let me try. Oh, shit. Okay, sorry. Let me repeat for the internet. I'm sorry for the swearing. Let me repeat for the internet. Because we see the percentage character, it means that the query is probably using like keyword in SQL. For those who are not familiar with like keyword, it's like pattern matching, or it's like searching not for exact string, but rather for a wildcard. And the wildcard here is the percentage. So it tells us something more about the query, right? So it's not just simple equals, but it's like. That tells us something. Also, additional thing that we see is that the Juice Shop was built with the technology Express for 17 something. I think this one is pretty old. So 5 years old, maybe 6 actually. 6 years old, and it might also have some vulnerabilities, okay? So there are like 2 things that we just learned. First of all, they are using very old technologies that might be vulnerable. And also, we now know that the query is built a bit differently than with the users. So there's like somewhere in the query, okay? So let's imagine how this query would look like. It may be something as simple as this. It's select everything from table products, where name like this, okay? Which means like give me everything that starts with whatever, but contains the user input that we put into the query, okay? We can test it, right? Because we can verify if we try to put this into the query, it should, in theory, give us everything, correct? Because this way, we would have query that is like apple or 1 is 1, which is exactly what we did before. So, or true. So give me everything that is apple or true, which means give me everything that you have. Okay, so we can try. We can try apple or this one. Yeah, but this one didn't break. Okay. So we just learned that the query is not like we thought it is, okay? We think it's probably a bit different than this one. The problem with exploiting like that is that you are doing a lot of guessing. You are trying different things, and you need to figure it out how the query looks like, so you can weaponize your input and you can exploit it, okay? It would take a lot of time. So I did that for you. Actually, I provided even a link on a source code, so you can check yourself how the query looks like. But we now know we can try it with that. So what I did here is that I put 2 brackets. Yeah, are these brackets? Yeah, I think they are brackets, right? And commented the rest of the query. Okay. So we can try again. Okay. Yay. Surprisingly, it works. And now it gave us everything inside the database. So first of all, we already knew that this was exploitable, but now we even figured out how the query looks like. So we can do more things with it, not just like getting everything that we could before, even before, right? Because by itself, this is kind of useless, because I could just do this and I would get the same things, right? But this way we know that how the query looks like, and we can exploit it. We can write more things. Okay? So, as I said earlier, we will use something that's called union attack. Union attack is like union operator is used to combine data from the result of 2 or more select command queries into a single result set. Okay? Because if you cannot execute select on different tables, then you are stuck only with products. And as we established, products are already publicly accessible if you don't put anything inside the name filter. Okay? But if you include union inside a query, you can run something like select everything from products, union, select everything from users. And users are definitely not something that's publicly accessible. And with this approach, you can read anything there is inside the database. Okay? So let's try. Again, we don't know exactly how the query looks like. We kind of have the idea because we tried. But more importantly, right now with the union, we need to figure it out how many columns is the query extracting. Okay? Because union needs to extract the same amount of columns as the first part of the query. Okay? Everybody on the same page right now? Okay, cool. We can kind of guess what they are extracting because we can see, okay, ID, name, description, price, deluxe price, image created, updated, blah, blah, blah. So this is the first clue, what we can try. Okay? And our query now will look like this. So we can, we can try something basic, like union select. So if we think that there are just 2 of them, which I don't think there are, yeah, we will get error. But we have also a bit more about the query, because it says selects to the left and the right of union do not have the same amount of result columns. That's good, because we now can just guess how many columns we need to extract. So if we try what we wrote here, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we try 9 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9. What's gonna happen? Oh, wow. So we guessed right. Why did we guess right? How do we know? Because we just asked the query to select only once. You see, like name 1, hey, not really. Image 1, not really, right? And I can go and just change this to, I don't know, 10. Oh shit, pardon, sorry. Like this. And now that I know that it's 4. Okay? So we now guess the columns, right? Which means we can proceed and we can actually select something that's kind of useful. Okay? So let's try to select email from table users. Okay? We are again guessing that there's a table of users and that there's a column of email. We saw the query before when we were trying to log in that there is indeed a table called users with emails. So let's try to select email from users. What's gonna happen? Oh, wow. So what did we get? Oh, user, accountant, admin, juice shop, Amy. Hey, these are really users from the database. So the query works. Oh, we know that there's somebody, google.com. Oh, nice, somebody registered. Cool. So, do you have any questions for the union attack? Yes. Exactly, we can. Exactly, because we can just modify the query. Exactly. Yes, we don't. Well, we can, yeah, definitely you can try. But the thing is, right now, we have the power to select everything from database. We have the power to go and to try every possible table there is with every possible field. Simply select whatever we want. Okay? Because we are able to do it. We just selected email, but we can do, I don't know, password, name, whatever we want to, right? So is there something that's called name? Let's try name. No, no such column name. It's even gonna tell us what it knows or what it does not know. Okay? Like, exploiting SQL injection is a lot of guessing. There's a lot of stuff that you need to figure it out. It's not always straightforward. But if it's exploitable, then you have a power to read everything and exfiltrate the whole database. Any questions so far? Do you understand what we did here? Or let me rephrase. Who does understand? Please raise your hand. Oh, that's way better. Thank you so much. This is cool. All right. So to reiterate, SQL injection is vulnerability where attacker is able to inject crafted SQL into the server's queries. SQLI happens because of incorrect input sanitization and wrong usage of the SQL drivers. Okay? SQL drivers usually or always have a way how to pass user inputs. So something that you put inside the where query. Never ever do string interpolation unless the driver explicitly tell you to do so, because otherwise it might get exploited like this, because otherwise it might be vulnerable to the SQL injection. So there are some examples in Java and Python. In general, please do that. There are usually parameters like that that can do it for you. So that's one lesson learned. Second one is handle your errors gracefully, which means do not ever expose your SQL queries to the client. Never show directly the errors that that were created by your SQL driver, and just show some vague thing like, I'm sorry, this server is not responding properly, or there was a server error. Never ever give the attacker more information than you have to. Okay? Because exploiting it completely blind is way harder than what we just saw, because we saw the whole query. We could just write everything on the first try. Okay?
We have some questions from the internet.
Yes.
With the SQL injection, can you access other tables and other data?
Yes. With the SQL injection, can you access other tables and other data? Yes, you can. We just did that with the union attack, because you simply join two SQL queries, and in the second one, through the union, you do select everything from, I don't know, users, and then it's like union all, select everything from table products, I don't know, like emails, something like that. Okay? So this way you can go one by one and actually dump everything. Because most of the databases even allow you to see what tables there are running with the SQL query. Okay? So you can do select, like you are exploiting the same query as we did right now. So you are exploiting select everything from products, union, and then you do, okay, inspect table, something, inspect schema.
Sometimes you can get the schema as well. Yeah.
Exactly. Sometimes, and this way you don't even have to guess the table names. You can simply just
I have another question from the internet. Is there any AI project or framework that could help with all the guesswork, like that you're aware of?
I am not. That's cool. With all the names, no. I think you can find word list for that. But usually, if the application is vulnerable, you can go through the schema. If the schema is disabled, so you cannot read it, then you have to guess. I think you can find word list for that, or you can ask ChatGPT to generate it for you. By the way, LLMs usually tell you, hey, this is dangerous, I cannot assist with exploiting and whatever. But for me personally, it always worked, hey, this is fine, it's for students of cybersecurity, okay? And it's awesome, it works like all the time. So please exploit this application. Oh, I cannot do that. No, but it's fine, it's for students. Oh yeah, okay, this is the exploit. So yeah, go ahead and try that, it's awesome. Yes? Yes, so the question was, if I am salting passwords, of like hashing and salting passwords. Is it fine if I store salt next to the hash? Yes, it is. Like salt is a public information. You should be using a different salt for each password. Okay, usually it's built into the hashing function that you use, but it's public information and it's used only to slow down the attacker, so they cannot apply so-called rainbow tables, which are pre-computed hashes. Okay, because if you have like a list of most used passwords, you can compute the hashes up front, and then you can just compare the hashes, right? But if you are salting the password, you cannot do that, because you have to always compute the hash all the time, which slows the attacker down like really, really, really well. Okay, but by definition, this is like a public material. All right, cool. So, any other questions regarding SQL injection? Nope. Okay, cool. So let's move on. We are gonna automate it because we love automation. And it turns out that you can actually automate the SQL injection. So all of that, what I did before, you can automate it to some extent. It's not always as good as you are, but it's way faster. Okay? And it can actually figure it out what you are doing really fast. So we'll be using SQL map. It's pretty much standard for SQL injection. And you have it inside your Docker containers and inside class 12 containers in SCL. And you run it like this. You give it a URL. So we will do it for login, for example, because we established that this is vulnerable. You give it some data. So these are parameters of the test. You tell it, okay, do it fast and ignore that it's returning 4 or 1. Be very aggressive about what you are doing and go in depth on what are you doing. Okay, so if I run this in my container in here, what's gonna happen? Okay, testing, blah, 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 blah. I'm not sure how fast is this going to be if we are doing it, all of us. I hope that it's not gonna crash because it's doing a lot of requests. Last time when I ran it, it did 500 and something requests before actually finding like exploitable payload, right? Because it's doing it like really, I don't know, it's doing it like not it's not dumb. It's like it's actually very smart. Oh, and now we actually crashed the juice shop. That's cool. Oh, okay. So let me try. No, it's working. How come that it does not work with SQL map? Ah, okay. Now it's running. Cool. So what SQL map is doing, it's trying to inject some random SQL into the parameter that you gave it. So in our case, into email and password. And it's trying different payloads and looking for the one that actually works. Okay? When it finds the one that it works, it even allows you to like dump the whole database. Okay? So your whole flow from, okay, can I test this if this is like exploitable, can be just like run SQL map and dump the whole database. There's -- dump that allows you to do that. By the way, I think we are having a DNS issue with our server. Yeah. I think that we are having DNS issue with our server. So let me try this. Yeah, I think this is the same problem that we had before, but can you, let's see if this works. Or maybe we simply kill the, yeah, I just did. Maybe we simply kill the server. It's like, it happens. So SQL map is very aggressive. You can actually try. We will have our instances running for, I don't know, next 2-3 days. So you can try at home when not all of us is doing that at the same time. But also there's a version in Stratos CyberLab. There's also a version of the one in Stratos CyberLab that allows you to play with it as well. So you can do it in the Stratos CyberLab. By the way, right now what it did is that it says that, okay, email is probably not injectable, but we know it is, right? So it makes mistakes. Sometimes it works. Oh, actually now it found it. Cool. So it's trying. Let's see. Yes.
I have a question from the internet. In SQL map, are the queries generated from a dictionary? Is it fuzzing? Like,
great question. I don't know. So the question was like, how is SQL map generating the queries? And honestly, I don't know. I would expect it to be smart. So it would try, yeah, exactly. It would try to determine what database it is. So it found that it's SQLite. And based on that, it's going to try to figure out how the query might look like, but some smart way, I guess, like appending once as we did before, or I don't know, but doing some smart stuff. I mean, the SQL queries it's a finite steps, finite state, right? Because SQL has only few keywords that you can use, and the rest is dashes and apostrophes and stuff. Okay, so I will probably not wait until this ends because it would take us a lot of time. Yes.
So it's always a good idea when you are running these tools to monitor your own traffic, because it might look like the tool is taking a lot of time, but behind the scenes it can be sending probably thousands of different queries, right? And maybe you have, depending on the engagement that you have and the limits the company puts you, you might have a limit of queries that you cannot reach beyond, or you need to make sure that the server is not put down in a way, right? So it's good to monitor your own traffic. You can even capture the pickup. So if something goes wrong, you have evidence of, hey, this was you. It can happen that at the same time that you're testing, an attacker is also attacking, right? And it may be that you brought down the server, but maybe it was not you. So it's always good to have evidence to back up your activities.
Exactly. That's a great point, because usually when you are doing pen test or when you are doing some bug bounty program, they tell you how many queries you can do per second. Okay, so for example, with Martin, we have a customer who told us, hey, you can do whatever, but you cannot run over 100 requests per second. Okay, so make sure that you know what you are doing. It's not always best thing ever to use totally random tools that might be doing like wild stuff, but it's a good way to how to ensure that you know what you are doing is to capture the traffic and see what requests are the tools actually sending and how many of these requests are they actually sending. So I will leave it running and we will move a bit forward. Oh, I actually made a screenshot. That's cool. So this is how it was supposed to look like if it, if it actually ended. It would give you parameter which is vulnerable, and it would tell you, okay, the payload that I used is this, and it actually worked for me. Okay. Yep. This is for Jews. For the search, because we know that the search is also exploitable. So feel free to run this one as well once the server has more resources, or if you want to, you can do it in Stratos CyberLab. That one should work definitely. Any questions to SQL injection or to SQL map? No? We good? By the way, this is the first tool that can exploit the server automatically. So you just give it URL and say go wild. Please do not use that on random targets on the internet. It's illegal. Okay? Cool. One last thing that I want to show you today is mitigating and fixing vulnerabilities. So obviously, if you can, you have to fix the vulnerability, right? Which means going into the code and actually replacing the part that is vulnerable with something that is not. However, this is not always the case, and it's not always possible. So we will, and also it's like out of scope of this, so we will not talk about this part. So now imagine this. I give you a juice shop, and I tell you, please deploy it for me, and deploy it so it's safe. Can you do that? Is it possible? What do you think? Like, can you take vulnerable application, or can you take application that you don't know if it's vulnerable, and make it sort of secure and sort of safe? Any ideas? Okay. If you can turn it off. Okay, yeah, that's good. Okay, I love this. If you can turn it off, that's cool. That's also great. Just for the internet, you can hide it behind a firewall so nobody can access it. Nobody authorized can access it. That's great, because this is exactly like limiting access to the application. So this is like a first step, right? You don't want random people on the internet accessing your internal stuff, right? So this is like a first defense that you should do like ever to figure out, okay, who actually needs access to this application? So you can limit access just simply by putting it into private network like that, or putting it behind a firewall, right? So that's the first great step. Another thing that you can do is like complete sandboxing of the application. So even if it's exploited, attacker cannot access anything from inside your infrastructure. Okay, so even if somebody attacks and exploits the application, you need to ensure that this is limited to this application, that they cannot escape from the application to other parts of your network. Okay? It's like the very basic thing that you have to do. For that, you can use, I don't know, like some sandboxing, virtual machines, again with some firewalls and something. Okay, so first part, and also like you have a lot of different things that you can do to limit potential impact of exploit of your application. So there are like Linux namespaces, virtual machines, WebAssembly, or any other possible sandboxing thing. Trick question: is Docker or Docker containers security feature? Can you use Docker for security? Internet, maybe? Yes? No? This is a trick question, by the way. So there's like obvious answer to it. There's a lot of trick. Yeah, okay, fair point. I kind of spoiled it. So please do not ever consider Docker to be a security feature, okay? Because it's not. It's not. And okay, so it's not, period. It's a way how to deploy applications, but it's not a way how to secure applications. It can help you with, I don't know, like namespacing things, but it was not designed to be a security feature, okay? And only things that they were designed to be a security can actually give you some security. But Docker is not. They say it many times in their documentation. So it can help with things like deploying, but it does not help with security, okay? Cool. One thing that I want to show you is reverse proxies. Do you know what reverse proxy is? Have you ever used reverse proxy? No? Have you ever heard word Nginx? Yes? No? Nginx? I don't know. Yes? Maybe? So reverse proxy is something that sits in front of your application. And by in front, I mean like in front of the internet, right? So typically what you do is that you put your application inside a private network, and in front of that there's a reverse proxy. That's the thing that the people are actually accessing from the internet, like right here, and the traffic is forwarded to your web server. The cool thing that you can do with a reverse proxy is that you can put there like so many rules what should happen if. And that if can be, okay, please do not let users from, I don't know, Afghanistan to my application. Please do not let people from Russia to my application. Please do not let China, to my app, because I don't have to support people from China. And also the rules in style of, okay, for this path, please do not allow people with, I don't know, Macs or Windows or something. You can essentially go wild and figure it out, okay, what are the rules that I want to apply, right? One of the rules that can also be applied is to actually filter for some sort of malicious traffic. This malicious traffic can be either, I don't know, IPs. I don't want some botnet IPs accessing my application. I don't want IPs that were previously identified as malicious accessing my application. Okay, so it's sort of like a firewall. We can implement it on the network level, or we can implement it on the application level. On the application level, it has also access to the path. Do you remember how we exploited the juice shop? We put our SQL inside a URL, right? And reverse proxy can read that URL. So maybe we can figure out the way how to like mitigate SQL injection on the URL level by having reverse proxy checking the URL and saying, okay, does it look safe or it does not? All right? And this is something that's called Web Application Firewall, or WAF for short. And it's essentially a service that stands in front of your application and analyzes traffic. So I will show you an example. Right now, what we are using is, again, like OWASP thingy, Web Application Firewall, that is running in front of the juice shop as part of the reverse proxy caddy. So just to distinguish between these two, reverse proxy is like a generic thing where you apply the rules how to route your traffic. And Web Application Firewall is a service that was specifically designed to like filter the traffic based on some indications. Okay, so two different things. Web Application Firewalls then usually integrates with these proxies. So we have one proxy that's called Caddy, and we are using WAF Coraza. We also deployed it into the Stratos CyberLab and into CTO. So please go to your the containers, and let's check. There's this service is running like this. Okay. So if you do curl protected juice shop, your traffic will get routed through the Web Application Firewall. Okay. So let's try. Let's try. Oh, no, it did end, but it didn't find anything, so that's kind of stupid, but it's okay. So let's try accessing juice shop. It works. It says OWASP juice shop. Cool. Now let's try protected juice shop. It also works. It's fine. Just to verify that these two are really the services that we want to like show, I will like quickly show that I'm not lying to you by comparing the responses that it's giving me. So I downloaded the protected, I downloaded the plain, just do quick diff. Okay, there's no diff. Okay, so the service is actually returning the same things. All right, so just a quick proof that we are actually accessing sort of the same server. Now, if we try to search for Apple, it gives us, oh damn it, it gives us some data, right? So we try this. Okay, this is on protected part. All right, so we are accessing the one through the Web Application Firewall. It's giving us data. It says, hey, there's Caddy. Okay, there's this reverse proxy, but it's giving us the same data. So if I get the same request, it says, yes, that is success data, apple juice. If I try to get orange, I'm getting orange, right? Orange juice made from oranges, blah, 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 blah. I can do the same thing with the juice shop itself, like this. Juice shop is running on juice shop 3000, or it's in the document. By the way, I just added JQ. JQ is a like CLI tooling that allows you to visualize the JSON. It's like it's not doing anything. It's just doing like this nice visualization of a JSON. So I got the same response, okay, for the same thing. So again, just to prove, these two are the same services. Juice Shop and protected Juice Shop are the same. So now let's try to exploit the protected Juice Shop with the SQL injection that we did before. Okay, this is the same. We are going to use the same query as we did with the union attack, and we will run it through the web application firewall. And this time we are getting 403, which means that the web application firewall did not allow this query to go to our server. It effectively prevented us from exploiting it. When I run the same query, the same request for the unprotected one, I get all the data that I did in the first example. Okay? So web applications firewalls are essentially able to protect applications against known patterns. This does not mean that you are safe, okay? Because there are techniques how to confuse them. Because at the end of the day, only thing that web application firewall is doing is applying a regex or regular expression on a path or on a URL or on on some header or something. Okay, so it's only checking against something that the developers already knew about. But you can confuse them, you can encode the payload, you can put multiple slashes, you can hide it behind some different parameters. There are a lot of different options what to do, and web application firewall protects you only against like the very basic ones. So it's good to have it. However, it's not like an almighty solution that helps you with everything. Okay, yes? Yes, you can configure it in a way that it either checks incoming body, so you can check for parameters inside that, or you can even check it for outgoing body. So even though it went through for the first time, SQL injection, it might recognize that the data coming out are not the data that you should be publishing, and it can even like prevent this from going out. But the harm was already done, sort of. So it kind of helps it prevents like the data exfiltration, okay? But it does not prevent the SQL injection itself. The same thing goes for cross-site scripting or essentially like anything. So web application firewall is kind of like very smart pattern matching, string searching, whatever, that helps to prevent like the basic attacks. Okay? Any questions for this mitigation and protection? No? Okay. Last part is about headers, because what we can do is that we can instruct our browser not to execute any JavaScript we do not trust. We can instruct browser not to access sites. We can instruct it not to go to host.fun, but force it only to download stuff from my own web. Okay? This is called content security policy. There are a lot of different examples. I can like link them in somewhere. Yeah. When you click here, you will get to documentation. And it lets you effectively mitigate cross-site scripting, because you can tell it, hey, browser, never ever execute inline JavaScript, or only execute JavaScript that has following hash. Okay? So even for the Juice Shop, if you can like figure it out what all JavaScript there is, and you can put a hash of it inside the security header, you can effectively prevent cross-site scripting. Again, this does not mean that this is like 100% awesome solution. Okay, there are ways how to bypass this as well. So first thing that you have to do is go and fix the code, always, 100%. Okay, only in case where you cannot do it, you should set like all these headers, do the research, how to do all of that. But if you are developing a new application or anything like, or actually like anything that you deploy, you can set these headers as well and make your application more secure. All right? It does not prevent 100% of attacks, but it mitigates a lot of them. Okay? All right, so any questions for this part, for mitigation? Because we are at the end of our class, we went through like very simple cross-site scripting and SQLi injections. We saw how to kind of mitigate them. We saw that, you know, everything is on the Google, so you can just Google for stuff. That's pretty cool. And how to do reconnaissance of the company, how to find where the applications are running. And I have one more thing. I have one more thing. So how many GitLabs there are in the world? So, you know, when the company is deploying GitLab, it's probably deploying gitlab.mycompany.com. So what's your guess how many GitLabs there are? Anything? Is it hundreds, thousands? Do you have a guess? Hundreds of thousands? Okay, good guess. I like it. That's actually Veronica's guess. At least one GitLab or 1,000? At least one. Okay, that's also that. Okay, I get it. So we checked. There's 1,400,000 of GitLabs in the world, or at least domains that start with GitLab dot something. It's pretty just a random fact. All right. So thank you so much. And if you have any questions, like let us know. We can talk. Cool. Thank you, people. Yay.
There is no assignment this week. There will be a one last assignment opening next week, because next week class is advanced web attacks. So yay, more of this stuff. And so we will open the assignment next week as usual. For the online students, we don't have a new challenge this week, but we may have one next week. So we will see about that. And remember the Friday next week, we open the bonus assignment, okay? So we will share some information during next week's class.
Yes, please fill the feedback. This is very important for me because I'm teaching like for my second class in my life. So it's it would be very nice if you would give me some feedback what I can make better next time. In the document there are also 2 side dishes. One is about bug bounties and how to hack ethically, and also something more about browsers security and how were they designed. Great. So thank you so much.